Next is question number 46, which says that if A, B, C and D are positive integers and A is less than B less than C less than D, such that A, B, C are in AP and B, C, D are in GP, and it has also been given that D minus A is equal to 60, then the number of unordered relatively prime natural number pairs with PQ equal to D is, right. We firstly have to find the values of A, B, C, D. Now let us assume the numbers as A, B, C are in AP. So the numbers can be assumed as A minus D, A and A plus D, and where this is A, this is B and this is C. And it has also been given that B, C, D are in GP. So the number D can be assumed as A plus D whole square upon A, right? Okay, now these are the four numbers. So we are given that D minus A is equal to 60. So let us put that A plus D whole square upon A minus A plus D is given to be equal to 60. So we have A square plus D square plus 2AD minus A square plus AD minus 60A is equal to 0, right? So cancelling these, we will get 3AD minus 60A equal to minus D square, right? So the value of A will be equal to minus D square upon 3D minus 60. That is, it can also be written as D square upon taking minus common and taking 3 also common. We can write it as 20 minus D, right? This is the value of A. Now it has been given that all the four numbers are positive integers. So this should be greater than 0. Now D square upon 3 is already positive. So 20 minus D is greater than 0, which means that D is less than 20. D is less than 20, and already we know that D is greater than 0. So moreover, here it can be checked that as A is an integer and here in the denominator we have 3, it means that D should also be a multiple of 3 so that A becomes an integer, right? So we can take either D equal to 3, or we can take D equal to 6, or D equal to 9, or D equal to 12, or D equal to 15, or D equal to 18. These are the possible values of D, right? Now corresponding to these, let's find value of A. That will be equal to 9 upon 3 into 17, but this is rejected and this is not an integer. Again here we will find A, that will be equal to 36 upon 3 into 14, that is also rejected, and here we will get A equal to 81 upon 3 into 11, that is also not an integer, and here we will get A equal to 144 upon 3 into 8, that is also rejected as A minus D is negative. From here we will get A equal to 225 upon 3 into 5, that is the value of A is equal to 15 from here, but one of the numbers is A minus D, that is 0, but the numbers are positive, so this is also rejected. And from D equal to 18 we will get A equal to 18 square upon 3 into 2. So the value of A will be equal to 54, right? So this is a possible case. So from here we get the four values as A minus D, that is 54 minus 18, that is 36, 54, 72, and the last value will be 96. So these are the four values of A, B, C and D, right? Now let's check the options. Option number A says that the number of unordered relatively prime natural numbers P comma Q with PQ equal to D is. Now PQ can be put equal to D. Now D is 96. Now 96 can be written equal to 1 into 96 or 2 into 48 or 3 into 32 or 4 into 24, 6 into 16 or 8 into 12. Now from these numbers it can be seen that only this number and this numbers are relatively prime to each other. So the number of unordered pairs are 2. Hence the correct answer will be option number A, and option number B is incorrect. Now also for option number C we have to find the number of positive divisors of AC. Now AC is equal to 36 into 72, that is equal to 2 times 6 raised to the power 4, that is equal to 2 raised to the power 5 into 3 raised to the power 4. So the number of positive divisors will be 5 plus 1, that is 6, into 4 plus 1, that is 5, that is 30. So from option number C and D, it can be seen that option number D is the correct answer, right? Next is question number 47, which says that a 9-digit number n is formed such that no digit is 0 and no two digits are identical. Which of the following options is or are correct? Okay, we have formed a 9-digit number in which all the digits from 1 to 9 have been used. Now, option number A says that the probability that n is divisible by 6 is, for divisibility by 6, a number should be divisible both by 2 and 3. Now, for number to be divisible by 2, the end digit should be 2 or 4 or 6 or 8. Now, for number to be divisible by 3, the sum of the digits should be divisible by 3, right? Now, the sum of the digits is 1 plus 2 plus 3 plus up till 9. It is an AP and its sum is 9 into 9 plus 1 upon 2. That is 45. Now, this is divisible by 3. So, the number will definitely be divisible by 3. So, the probability will be equal to, now for end digit we have 4 options, and for the rest the numbers can be arranged in 8 factorial ways, and total number of ways are 9 factorial. So the probability will be equal to 4 upon 9, but here it have been given 1 by 2, so this option is incorrect. Now let's move on to option number B, which says that the probability that n is divisible by 12 is, now for number to be divisible by 12, it should be divisible by 4 and 3. As we have already discussed, the number is definitely divisible by 3. We just have to ensure that the number should be divisible by 4. Now, for number to be divisible by 4, last two digits should be divisible by 4. So let's check out what are those numbers. The numbers can be 12, as we are not using 0 here. So the number can be 12 or 16 or 24 or 28 or 32 or 36 or 48 or 52 or 56 or 64 or 68 or 72 or 76 or 84 or 92 or 96. Only these are the two-digit numbers that will be divisible by 4 when 0 is not used. So how many numbers these are? So these are 16 numbers. So required probability 16 times 7 factorial upon total number of ways are 9 factorial. So this is equal to, in the denominator we have 8 into 9 and in the numerator I have 16. So this will be equal to 2 by 9. So option number B is incorrect and option number C is correct. Now option number D, in which we have to find the probability of n being divisible by 11. Now for divisibility by 11, let us say O is the sum of digits on odd places and E be equal to sum of digits on even places, right? So firstly, O plus E should be equal to 45. The sum of all the digits is 45. Also, O minus E modulus should be equal to a multiple of 11, because we know that a number will be divisible by 11 if the sum of the digits at odd places minus sum of digits as at even places is a multiple of 11. Then the number is divisible by 11, right? So O minus E modulus will be equal to multiple of 11. Now that is, it can either be equal to 11 or, now this number should be an odd number, right? Because if O minus E modulus is an even number but O plus E is an odd number, then it will not be a natural number, right? So it should be odd. So the only possibility is that O minus E mod should be equal to 11. So from here we will have either O minus E equal to 11 or E minus O equal to 11, right? So from here we get that if I add these two, we will get O equal to 56 upon 2, that is 28, and E will be equal to 17. And from the second condition, we will get O equal to 17 and E equal to 28. These are the two conditions. Now, to get the sum at even places to be equal to 17, right, we have 4 even places, right? We have 4 even places. Its sum should be 17. See, let's see how we can get that. Let us say we take first digit as 9. Then the other can be taken as 1, 2, 5 or 1, 3, 4. These are the only cases. Now, if I take 8 at first place, then at others I can take 1, 2, 6, 1, 3, 5 or 2, 3, 4. Right? These are the cases. And if I take 7 at any one digit, then we can get 1, 3, 6 or 1, 4, 5 or 2, 3, 5. Also, one more case is if I take 6 here, then the numbers can be 2, 4 and 5. So these are the only cases. Now further let's solve for E equal to 28. Sum of any 4 numbers should be equal to 28. Now it can happen in how many ways? Either it can be 9, 8, 7, 4 or 9, 8, 6, 5, right? These two are the only cases. So in total we have 11 cases, right? So the probability will be equal to 11 into. Now these odd numbers should arrange among themselves and the even numbers should arrange among themselves. So we will write 4 factorial into 5 factorial for them, and in the denominator we have 9 factorial. So this will be equal to 11 into 24 upon 6 into 7 into 8 into 9. So solving this, we will get it equal to 11 upon 126, which is given in option number D. So option number D is also the correct answer. Next is question number 48, which says that for x comma y belonging to R, x square plus y square is greater than 0. This condition means that x and y both are not at a time 0, right? Now, the minimum and maximum value of the expression x square plus y square upon 2x square plus xy plus 3y square are m and m respectively, right? That is, we have to find the range of this function. So, we can assume x equal to r cos theta and y equal to r sin theta. So, let us say the value is equal to lambda. So, this will be equal to x square plus y square, that is r square. And in the denominator we will have 2 into x square, that is r square cos square theta plus xy, that is r square cos theta into sin theta plus 3 times y square, that is r square sin square theta, right? Now r square can be taken common from the numerator and denominator, and multiplying by 2 numerator and denominator, we will get 4 cos square theta plus 2 cos theta sin theta, that can be written as sin 2 theta plus 6 times sin square theta. So this is equal to 2 upon 4 cos square theta plus 4 sin square theta can be written as 4 plus 2 sin square theta plus sin 2 theta. Now we know that cos 2 theta is equal to 1 minus 2 into sin square theta. So let us put it here. So we'll get 2 upon 4 plus 2 into sin square theta is 1 minus cos 2 theta plus sin 2 theta. So this can be written as 2 upon 5 plus sin 2 theta minus cos 2 theta. Now its range can easily be found now. Now maximum value is capital M. That will be equal to, it will be maximum when the denominator is minimum. So the denominator is minimum means that the value of sin 2 theta minus cos 2 theta is minus root 2, and the minimum value, that is small m, will be obtained when the denominator is maximum, that is 5 plus root 2. So these are the values of m and m. Now this question can also be solved if here we put x by y equal to t, and then we take the expression equal to lambda, and then we can make quadratic in t and the discriminant can be put greater than equal to 0. From there also we will find the range of the function. So from the given options it can be seen that option number A is correct and option number D is also correct, right? I hope the question is clear. Now let's move on to the next question, that is question number 49, which says that in the triangle ABC, if cos A by 2, cos B by 2, cos C by 2 minus sin A by 2, sin B by 2, sin C by 2 is equal to 1 by 2, then we have to comment about the circumcenter and orthocenter of the triangle. See, we already know about the values of cos A by 2 and sin A by 2. That is, cos A by 2 is equal to under root S into S minus A upon BC, and the value of sin A by 2 is equal to under root of S minus B into S minus C upon BC. Similarly, we know the values of cos B by 2, cos C by 2 and sin B by 2 and sin C by 2. So let us put the values here. So we will get under root of S cube into S minus A, S minus B into S minus C upon ABC, minus from here we will get S minus A, S minus B, S minus C upon ABC. Now this is given to be equal to 1 by 2. Now from first term if I take S common, then we will get here delta minus multiplying in the numerator and denominator by S, we will get here delta square, and ABC can be put on the other side, so we will get ABC upon 2. Further, this can be written as S minus delta upon S is equal to ABC upon 2 delta. That can further be written equal to S minus in radius, that is small r, equal to 2r, because we know that ABC upon 4 delta is equal to r. Now this condition is true for right angle triangle. This can also be proved. Let us say I have a right angled triangle here, A, B and C, where this side A is equal to 2r, and we know that r is equal to S minus A into tan A by 2, where angle A is 90 degrees. So r is equal to S minus A into tan 45 degrees, that is 1. So putting the value of A as 2r, we can write S minus r equal to A, that is 2r, right? This is what have been written over here. So this condition is possible only for right angle triangle, which means that the given triangle ABC is a right angle triangle. Now the option says that circumcenter lies on one of its vertices. Now for a right angle triangle we know that A is orthocenter and the circumcenter of this triangle is midpoint of BC. So we can say that the circumcenter lies on one of the sides and orthocenter lies on one of the vertices. So from the given options we can see that option number B and C are the correct answer. Next is question number 50, which says that if summation r equal to 1 to 4, r square xr is equal to 6. Similarly, two more summations have been given to us. Now here I can assume fx equal to x square into x1 plus x plus 1 square into x2 and so on up to x plus 3 whole square into x4. Let us assume fx equal to this. So what we are given from the first condition, if I put x equal to 1, so it will be f of 1 equal to 1 square into x1 plus 2 square into x2 and so on, that is given to us. So we can say that f of 1 is equal to 6. Also, if we put here x equal to 3, so it will be equal to 3 square into x1 plus 4 square into x2, and that is what have been given here. So f of 3 is equal to 18. Also, if I put x equal to 5 here, so f of 5 will be equal to 5 square x1 plus 6 square x2 and so on, and that is what have been written here. So this is equal to 38. Now it can also be observed that fx is a quadratic polynomial. So let us assume fx equal to ax square plus bx plus c. So three conditions have been given. and 3 unknowns are there, so we can solve it. That is f of 1, that is a plus b plus c, is equal to 6, and f of 3, that is 9a plus 3b plus c, is equal to 18, and f of 5, that is 25a plus 5b plus c, is equal to 13, right? So let us say these are equation number 1, 2 and 3. If I subtract 1 from 2, so we will get 8a plus 2b equal to 12, that is 4a plus b is equal to 6, and 3 minus 2 will give me 16a plus 2b equal to 20, right? That is 8a plus b is equal to 10. So if I solve this, we will get the values of a, b, c as a equal to 1, b equal to 2 and c equal to 3. So putting these values back, we can find the function fx equal to x square plus 2x plus 3. This is the function fx. Now let us see what we have to find. In option number A, we have to find, let us put r equal to 1 here, 2 square into x1 plus 3 square into x2 and so on, right? That is the value of f of 2, right? This is the value of f of 2. So this will be equal to 4 plus 3. That is equal to 11. So option number A is correct. Similarly, let's find in option number B, we have to find 4 square into x1 plus 5 square into x2 and so on. That is, we have to find f of 4. That is equal to 16 plus 8 plus 3. That is equal to 27. So option number B is also correct. Now, in option number C, it have been asked 0 square into x1 plus 1 square into x2 and so on. That is, we have to find f of 0. That will be equal to 0 plus 0 plus 3. That is 3. But here it is given 2. So this is incorrect. In option number D, we have to find similarly f of minus 1. That will be equal to 1 minus 2 plus 3. So the value is equal to 2. So we can say that option number D is also the correct answer.